All right, 12.3 is on inscribed angle. So an angle whose vertex is on the circle and whose sides are chords of the circle is an inscribed angle. And an arc with endpoints on the sides of an inscribed angle and its other points in the interior of the angle is called the intercepted arc. Mostly we'll be working with inscribed angles, but just so we have all of the terminology. So let's look at this picture. The inscribed angle is actually this angle right here, which is made up of these chords. And inscribed means it is on the circle. So the vertex is on the circle. We want to write that on the circle. Okay, so then the intercepted arc is just right here, what the arc is opened to. All right, so how we're going to solve for inscribed angles. The measure of an inscribed angle is half the measure of its intercepted arc. So the measure of an inscribed angle is half the measure of its intercepted arc. So in this particular situation, we have the measure of angle B. Vertex on the circle is half of arc AC. So a lot of times we just call this like the measure of the angle equals half the arc, okay? Measure of the angle is always half of the arc. So what are the values of A and B here? Let's figure out what information we have. So A is this arc right here. All right, it is made up from this chord and this chord, which tells us its inscribed angle is 60. Now 60 should be half of the arc. So the arc should always be what is bigger. So you can always, so the opposite of halving something is to double that. So doubling 60 means A is 120. Okay? And that is the measure of the arc, so we're going to call that 120 degrees. Now that's an inscribed angle. We still know central angles are equal to that arc, but inscribed are going to be half. All right. Now let's look for what information we can get about angle B. So angle B is right here using those chords, which means it has to use all of this arc. So now that I know this is 120 and that is 30, that makes a total of 150. So I know my angle B has to be equal to 1/2 of the arc that it goes with, which is 150, which means B is 75 degrees. Okay, so it's always just important to draw on these pictures to figure out which arc or which angle goes with which parts. All right, so let's try this example. What's the measure of angle A, B, C, and D? So measure of angle A, B, C, and D. So angle A right here uses those chords, so I'm using all of that. So I have to use the 100 and the 90. So I am doing half of 190 is 95 degrees, okay? Half of the arc. All right, now we're gonna look at B. Uses these chords, so I need to use 64 and 90 as the whole arc that angle B uses, which makes 154. So I am finding half of 154, and that is 77 degrees. Angle C uses this chord and this chord. So I need to add 64 and 106 to be the whole arc. That adds to 170. So then I half that whole arc and I get 85 degrees. And then lastly, angle D uses this chord and this chord. So this whole arc is 206. And then I'm going to take half of that. So the measure of angle D is 103. Okay? So we have 103, we had angle C was 85, we had 77, and we have 95. All right? And then we had all those arcs that go with it. So here are some corollaries to this theorem about inscribed angles. So basically just some things that we need to know that we may see. So two inscribed angles that intercept the same arc have to be congruent. Well, you would get that whether you were just solving or remembered this theorem, okay? So angle A right here has these chords, which uses this arc. So it would be half of whatever that arc was. Well, angle B uses this chord and this chord, which ends up having the same arc. So they used different chords, but it had the same arc. So if this arc was 100, either way you would take half, and this one would be 50, this one would be 50, which makes them the same. So even if you don't remember this corollary, you can easily solve for it and find those are equal, but if you remember it, then it's easy to solve. The second one, corollary number 2, says an angle inscribed in a semicircle has to be a right angle. Well, that can also come from solving. So this arc right here is part of a semicircle because its points are ends of a diameter. So I know this arc has to be 180. Well, 180 divided by 2 is 90, so that's how I know this inscribed angle is 90 that uses this arc. All right? And then the last one, the opposite angles of a quadrilateral inscribed in a circle are supplementary. This is the only one that you really need to memorize because the others can come from solving. All right? So normally on a lot of quadrilaterals that we know that opposite angles are congruent, like in a parallelogram or a rhombus, things like that. But in this case, the opposite ones are actually going to be supplementary. So it's just something you need to think about with when they're inscribed in a circle. So for instance, if angle B was 80, across from that is D, so that would have to be 100 because 180 make 180. Okay, so let's try some examples. What is the measure of each numbered angle? So angle 1 right here is on my circle and it uses these chords. So this is the arc. Well, this right here is a diameter, which means that has to be 180. So angle 1 has to be half of 180, which is 90 degrees. All right, now example B over here. I'm trying to find angle 2, which uses those chords. So it uses that arc. So this 70 right here is not really very helpful because it's not the arc that I need. This 38 uses this chords, which happens to be this arc. So in case you didn't remember corollary number 1, we can do 38 times 2, which is 76 for this arc. Well, then angle 2 uses that arc as well, so it's got to be half of 76. So angle 2 is 38 degrees. All right, but if you did remember your corollary, then you know that those two angles are congruent because they used this same mixed arc right here. All right, this theorem, last one. The measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So basically, it is the same formula. There is nothing new here, okay? This is still an inscribed angle. It's just that it's not two chords. It's one chord and one tangent line, but it's still going to be half of this arc right here. So let's try an example with this. In the diagram, SR is tangent to the circle. So SR right here is tangent, so it's only going to intersect at one point. So this should actually say if the measure of PMQ is 212. So that is an arc. So PMQ is 212. What is angle PQR? So I'll put a question mark there. All right? There's a couple ways we can solve this. So for one, when we have a tangent line, since it intersects at just one spot, all the way around the circle, meaning back at the spot, is going to be 360 degrees. So 360, oops, not divided. We're going to subtract 212. And we get 148. So then I know the rest of this arc right here is 148. And then 148 divided by 2 is 74. So then this angle right here is 74 degrees that we were trying to find, okay? Only because tangents intersect at one point, you actually have all 360 degrees right here up until that point. Now, the other way you could have done this is this. So you still know PMQ is 212. You are still trying to find this. Well, you could take half of 212, which will be 106 right here. And now on a straight tangent line, you have 180 total degrees. So 180 minus 106 is also going to be 74 for that missing angle. Okay, so a couple ways you could do this using all of your information about tangent lines and inscribed angles. All right, bring these notes filled into class.